There is a boundary surrounding our solar system that no telescope can photograph, no probe can cross, and no signal can ever breach. It is not made of matter. It has no physical wall, no edge you could point to against the night sky. And yet it is among the most consequential structures in the entire history of cosmological thought. It is the cosmological event horizon, and it is the reason that the universe itself, operating through the cold mathematics of general relativity and accelerating expansion, is in the process of permanently erasing entire civilizations from our observable reality. To understand why, we need to first dismantle one of the most deeply held misconceptions about the nature of space. When most people imagine the cosmos, they picture something like an enormous darkened room. Stars are scattered across this room like points of light on a ceiling, and light simply travels from one side to the other. The room is large, enormously large, but it is fundamentally static. It sits there holding its contents while light moves through it at 300,000 kilometers per second. In this picture, the reason we have not heard from other civilizations is a matter of distance and time. We just need to wait long enough, build a sensitive enough receiver, and eventually something will answer. That picture is wrong. Not approximately wrong, not wrong in some peripheral philosophical sense, but physically, mathematically, categorically wrong. Space is not a static room. The geometry of the cosmos is not sitting still while light travels through it. The fabric of space-time itself, the very metric of the universe, is expanding. Every moment, new space is being generated between every point in the cosmos, and the rate at which that space is being generated is not constant. It is accelerating. Understanding why that single fact seals the fate of contact between civilizations requires going back to the equations of general relativity and to the physical agent driving this acceleration, which we call dark energy. Einstein wrote down his field equations in 1915, and they described a universe that could not remain static. The mathematics of general relativity, when applied to a cosmos filled uniformly with matter, predicted that the geometry of space had to be either expanding or contracting. Einstein was so uncomfortable with this result that he introduced an additional term into his equations, a constant he called the cosmological constant, intended to hold the universe in equilibrium. He later called this decision the greatest blunder of his career. Hubble's observations in 1929 confirmed that distant galaxies were receding from us. Their light stretched to longer wavelengths by the very expansion of the space through which that light had traveled. The universe was expanding after all, just as the unmodified field equations had predicted. But here is where the story deepens considerably. In 1998, two independent teams of astronomers were measuring the rate of expansion by observing Type Ia supernovae, which are extraordinarily consistent in their intrinsic luminosity and therefore serve as reliable distance markers across cosmological scales. What they expected to find was a universe decelerating under the gravitational pull of its own matter, slowing down as gravity gradually reasserted itself over the expansion seeded by the Big Bang. What they found instead was the opposite. The expansion of space was accelerating. Something was pushing space-time apart with increasing force, and that something was a form of energy permeating every cubic centimeter of empty space. We call it dark energy, and the best physical description we currently have for it maps almost exactly onto that cosmological constant Einstein introduced and then abandoned. Empty space carries energy. The vacuum itself has a positive energy density, and that energy density acts as a repulsive pressure on the geometry of space-time, driving the metric apart. Now, take a moment to sit with the physical consequences of that reality. If the vacuum of space carries energy that accelerates the expansion of the metric, then as the universe grows larger, the total amount of vacuum energy grows with it. More space generates more vacuum energy, which drives faster expansion, which generates even more space. On local scales, gravity still dominates. Galaxies and galaxy clusters remain gravitationally bound, held together by the cumulative mass of stars and dark matter pulling inward. But on the largest scales, at distances beyond roughly 4 billion light-years, the expansion driven by dark energy overwhelms gravity, and the geometry of the cosmos is being stretched apart at an ever-increasing rate. This is where a carefully chosen analogy becomes essential for grasping what is otherwise a deeply counterintuitive piece of geometry. Imagine placing two ants on a perfectly flat, perfectly elastic rubber surface. If the surface stays still, the ants can walk toward each other and meet without any difficulty at all. Their walking speed determines only how quickly they arrive. Now imagine that someone begins pulling the edges of that rubber sheet outward in every direction simultaneously, stretching the surface itself. If the stretching is slow, the ants can still make progress toward each other. Even though new rubber is appearing between them, they are walking fast enough to close the gap. But now suppose the rate of stretching is not constant. Suppose the person pulling the rubber is pulling harder and harder over time, stretching with accelerating force. At some critical separation distance, the space between the two ants is being generated faster than the ants can walk. One ant is moving toward the other at its absolute maximum velocity, but the gap between them is nevertheless growing. The ant is not standing still. It is running as fast as it physically can. But it is losing ground. Every step forward is more than erased by the stretching of the surface beneath it. The two ants will never meet, not because they stopped trying, not because they ran out of energy, because the geometry of the surface connecting them has been rendered permanently impassable. This is the precise physical situation that governs any attempt at communication between civilizations separated by cosmological distances. Replace the ants with photons, the fastest possible messengers in nature, traveling at 300,000 kilometers per second. Replace the rubber sheet with the three-dimensional fabric of spacetime. The expansion of the universe is not moving galaxies through space like objects thrown across a room. The galaxies themselves are largely stationary in their local reference frames. What is happening is that the space between them is growing. New metric is being generated at every point in the universe, and the rate of this metric expansion, quantified by what cosmologists call the Hubble parameter, is increasing due to the energy density of the dark energy field. The Hubble parameter describes how rapidly the recession velocity between two comoving points increases with the physical distance between them. At the current epoch, two locations in space separated by roughly 14 billion light-years are receding from each other at precisely the speed of light. This characteristic distance is called the Hubble radius. Any galaxy currently sitting beyond this radius is receding from our position at superluminal speed, not because it is moving through space faster than light, which special relativity absolutely forbids, but because the space between us and that galaxy is being created at a rate that translates to a recession velocity exceeding the speed of light. General relativity does not prohibit the expansion of the metric from proceeding faster than light. It only prohibits matter and information from moving through space faster than light. These are categorically different phenomena, and this distinction is what makes the cosmological event horizon so absolute in its consequences. The cosmological event horizon is defined by the interplay between the finite speed of light and the accelerating expansion of spacetime. Any photon emitted right now from a source beyond this horizon, which currently sits at a proper distance of roughly 16 billion light-years, will never reach us. Not because the photon is too slow in some relative sense, not because the journey is merely long, but because the physical space between that photon and our position is being created faster than the photon can traverse it. The photon moves forward at 300,000 kilometers per second through its local patch of space. But that local patch of space is being carried away from us faster than the photon advances through it. The photon is on a cosmic treadmill, moving in the correct direction but at a speed permanently insufficient to overcome the rate at which the treadmill is accelerating beneath it. It will move forward forever, cover enormous distances, and never close the gap. Now consider what this means when applied not to abstract geometry, but to the actual distribution of civilizations across the cosmos. The universe is estimated to contain somewhere between 100 billion and 2 trillion galaxies within the currently observable sphere, the region from which light has had time to reach us since the beginning of cosmic time. Each of those galaxies contains hundreds of billions of stars. A significant fraction of those stars host planetary systems. The statistical weight of these numbers makes the existence of other forms of complex chemistry and organized matter extremely difficult to discount on purely probabilistic grounds. But the operative question has never simply been whether life exists elsewhere. The operative question is whether any civilization capable of communication exists within the shrinking region of space from which causal contact remains geometrically possible. And here the physics becomes genuinely, precisely sobering. The cosmological event horizon is not a fixed boundary. Because the expansion of space is accelerating due to dark energy, the horizon is contracting in comoving terms over cosmological time. The region of space from which signals can ever reach us is not staying the same size. It is getting smaller. More and more of the universe is crossing beyond the boundary from which light can travel to our position before the geometry renders such travel impossible. Galaxies that are currently visible to us, galaxies whose photons are arriving at our telescopes at this very moment, are in many cases galaxies from which we are already causally disconnected in the present. The light arriving tonight was emitted billions of years ago, when those galaxies were positioned well within our causal boundary. But if those same galaxies attempted to transmit a signal toward us right now, that signal would be geometrically prohibited from ever arriving. The present universe has already moved beyond what the historical light is showing us. This is a point worth dwelling on carefully, because it cuts against the intuitive sense that a visible galaxy is an accessible galaxy. What we see when we look at the night sky is not the current configuration of the cosmos. It is a layered historical record, each photon carrying information about the position and state of its source at the specific moment it was emitted. Some of that information is billions of years old. The universe we observe through our most powerful telescopes is a superposition of many different eras of cosmic time. The causal structure of the present universe is already profoundly more isolated than the observed universe would suggest. The thermodynamic implications of this structure are no less striking. As the accelerating expansion continues, every gravitationally bound island of matter, every galaxy cluster and its satellite galaxies will become an increasingly isolated system. The light from distant galaxies will be redshifted to longer and longer wavelengths as the expansion stretches the photons in transit until eventually those photons carry so little energy they become undetectable. At the same time, the photon sphere of the observable universe will shrink inward as sources crossing the event horizon cease contributing light to our sky. In the very far future, the only galaxies a civilization within the Milky Way could ever observe, communicate with, or receive signals from will be the members of the local group, our small, gravitationally bound neighborhood of a few dozen galaxies held together against the expansion by the dominant local gravity. Every other galaxy in the observable universe will have been permanently removed from causal reality, not destroyed, not gone in any absolute sense, but sealed beyond a geometric boundary that no physical process can breach. Consider what that means for any civilization sending signals today. Somewhere in the Virgo cluster, roughly 50 million light-years from the Milky Way, and currently well within our causal reach, there could exist a civilization that has been transmitting structured electromagnetic signals for millions of years. Those signals may be traveling toward us at this moment, but the geometry of space-time and the energy density of the dark energy field are already working against their eventual arrival. The expansion of the metric is incrementally stealing ground from every photon in transit. For signals originating from sources closer to or beyond the current event horizon, the mathematics of the cosmological constant has already rendered arrival impossible. For sources within our observable sphere but far from the local group, the window for causal contact is finite and shrinking. This is the physically precise answer to the apparent silence of the cosmos. It is not a silence born of extinction, of civilizations that rose and fell before their signals could reach us. It is not a silence of indifference or deliberate concealment. It is a silence enforced by the geometry of space-time, by the energy density of the quantum vacuum, by the inexorable mathematics of metric expansion operating at cosmological scales. The universe has a built-in mechanism for isolating its contents from one another, a mechanism rooted not in any contingent feature of biology or technology or the choices of intelligent beings, but in the fundamental structure of the field equations that govern the curvature of space and time, every civilization that has ever existed or will ever exist in the universe beyond our local group is being carried away from us on the expanding metric. Some of them may have looked out at their own night sky and made precisely the same calculation we are making now, arriving at the same conclusion with the same quiet precision. That they are alone in their observable cosmos, not because the universe is empty, but because the laws of physics have built an infinite and accelerating wall of empty space between every gravitationally bound island of matter in the cosmos. The wall is not visible. It has no surface, no texture, no physical presence you could encounter on a journey outward from our galaxy, but it is absolute and it is growing. The night sky in this light is something more than a canvas of stars. It is the outer surface of a causal bubble, a sphere of diminishing radius within which the laws of physics still permit the exchange of information. Outside that bubble, an uncountable number of galaxies continue to form stars, to host worlds, to harbor whatever arrangements of matter and chemistry the universe produces in its long history. But they are permanently beyond reach, not as a consequence of their distance alone, not as a consequence of the finite speed of light alone, but as a direct consequence of the mathematical relationship between the cosmological constant, the energy density of the vacuum, and the rate at which the metric of spacetime is expanding. The universe is not hiding civilizations from us by accident. It is doing so by law.